me to start recording. All right. Okay, so here we go. All right. So in the last week session, we had discussed about basics of big data, and we understood that a data for which we require distributed computing is big data. All right, we talked about characteristics of big data. Then we had discussed about if a petabyte data big data. The answer was yes. And then we talked about various components that impact the computing. We also talked about the case studies of various use cases in the big data domain. Right? We took only very few examples such as sentiment analysis and recommendations. We also talked about various solutions available, and we talked about something called Hadoop. Okay, Hadoop is an ecosystem of various components. Okay, the lowest layer is called the file system, and then that file system basically can be is used across various machines. Okay, so we'll go into the details of the file system. All right. Okay, so all right, there are two questions. Let me answer those questions, and then we will uh, talk about do the recap. Okay, or maybe let me finish the recap and then I'll take a look at the questions. All right. All right, so the most important component of the ecosystem is Hadoop distributed file system. And this Hadoop distributed file system is used by almost every component. We will discuss the reasons behind its design, and we will also talk about the architectural details. All right. So on top of HDFS, you have Yarn. Yarn is kind of an operating system which tracks which machines are free, which machines are busy, who is running what. All right. MapReduce utilizes Yarn. MapReduce utilizes Yarn to MapReduce utilizes Yarn to execute your workload. Okay, the workload which you assign to MapReduce is in the form of map and reduce. You create map function, reduce function, hand it over to MapReduce. We will touch upon MapReduce during the course. And the other form of computing or other form of workload is Spark. Again, in Spark also, you kind of hand over the logic in the forms of maps and reduces, and then Spark gets that done on Yarn. Okay. Next is the HBase. HBase is a humongous database that utilizes HDFS to store the data in the form of files, while HBase provides us the database in the form of uh, in the tabular format, so that you can store the data which is structured. On top of MapReduce, you have Hive, Piglatin, and Mahat. So Hive and Piglatin provides you SQL kind of structure so that you don't have to write the code. While Mahat provides you the libraries which are used by Mahal provides you the libraries which are used for machine learning. All right. Okay. The next one is Uzi, and Uzi is nothing but a workflow kind of an engine which makes it possible to execute the workflow on top of Hadoop, meaning your program, your project might include various components. Some components, some part of the project is dependent on Hive. Some project part of the project is having Piglet in script. Some project is having interaction with HDFS, and some project is having the hardcore Java MapReduce or YARN. So in those cases, you use Uzi to schedule your work on the cluster. All right, that's what we had discussed last time. Okay, and all right. Next was the problem with. Okay, so we will talk about HDFS, and we will also talk about the problem with MapReduce. Okay, and then we will basically come back to this once more. All right. So similarly, we have got Spark, which is running on top of Yarn. Spark can run on top of Yarn, Amazon EC2, standalone, and Apache Mesos. Okay, those are the resource manager, meaning just like in a single computer, you have operating system which knows and interacts with various hardware. In the same way, Yarn interacts with all the machines in the cluster to understand their status and accordingly assign the work. Same is the job of Mesos, standalone, or EC2. All right. This Spark core can read data from any of these places, and Spark core provides you these libraries. Okay. The most important libraries are MLlib, streaming, and GraphX. These are the libraries, one for processing graphs, other for machine learning. MLlib is for machine learning, GraphX is for graph processing, and streaming is for processing real-time data. Next is that user can interact with the system using SQL, SparkR, Java, Python, Scala. So that was a quick architecture of Spark. All right, that's a quick architecture of Spark. We discussed this last time. Now, today we are going to talk about HDFS. We'll give you an overview of CloudX Lab so that you all can start working on that. Okay, let's take a look. Okay, so there are three questions. Let me try to answer those. One question is, under my course in Big Data, I see Python added, but not Unix or Scala as discussed in the last class. So Scala is all right. So the Unix part, okay, Unix video we will add. Actually, the team has sent the video in the email. We will add it as a separate course. Okay, right now it is just a separate video. Okay, and we will put it as create a separate course out of it. And Scala, with respect to Scala, we are going to learn it in live class. Okay, all right. And let me also share these notes for today right away, so that in case you have a question, in case you want to do what I'm doing, it'll be easier for all. Okay, I'm sending the link to all of you so that you can right away open these notes and also see this. Okay. Okay, a question from Jayaprakash. Could you tell what will yarn do? We will go into the details of yarn, don't worry. What's the advantage of using HDFS over? This is also we are going to discuss in detail. All right. Could you please explain one more time about Spark? Yes, we will go into the Spark's detail again after we finish HDFS. All right. Next question is okay. All right. Yes, we will do that. Okay, Jan, we will go into the details again. Exactly how does it work? And yes, we will also go into detailed interaction between any process such as MapReduce or Spark, the way they talk to Jan. All right. A question from Saba is, where is okay? All right, I'll do one thing, Azan. I'll share the slides which I'm showing right now with you, as in, okay. So you can actually see it in the okay right now. That's the advantage of using these technologies as of today. So to solve the problem right now, we have given you the access to the today's slide, all of you. Okay, this is today's presentation. All right. And I'll also share the other three talks today we are going to go with. All right. Good. All right. So yes. All right. We will be updating all of this content in the LMS. All right. So most of the questions which you have, we are going to deal with them as we go forward. And so we are going to basically go into decent amount of detail. All right. So some of you are having a question related to Linux and others. So I would like to quickly take you over the session. Will you be okay to go through Linux once again, everyone? Should I? I'll just go through the basic commands and that should be good. All right. And let me also share this one, the one I'm using right now, so that we can effectively, communicate. So yes, and this is our Linux presentation. All right. Okay. This particular links, please do not share these, and they will be not usable after a point of time. Okay. All right. So how many of you want me to go through Linux and console and that you want me to touch upon those two? Yes. All right. Looks like Anuja's question is where to see links not received an email or will it be available on No Big Data? This will be available on No Big Data. For time being, I've shared the intro, this particular text file you see here. I've just shared with you this one, so you can quickly see whatever we are talking right now. Okay, does that sound okay, Anuja? Great, great. So most of this content, I mean, we try to keep even the today's webinar link here. You can see that in the session. Just that for some reason these are not reflecting. I'll have to take a look again. All right. Here you can see the Linux presentation, basic commands, and so on. All right. I think I'll swap this. I will first take up the Linux command in second session rather than waiting for some more hours. All right. Yes. So is everybody able to see the notes, these notes as I type in? Because that'll be quite useful. I've just shared on the questions window, and you should see that as an inside an answer, the link to it. Okay, this one. All right, good. So let's move ahead, and looks like everybody is interested to learn a little bit about Hadoop. I mean, learn a little bit about Linux console. Yes, is that so? So I see, okay, 7 people interested in learning basics of Linux. Good. Let me just go over it. I won't try to, wait for it too much. I would not jump into the details of Linux. Okay. All right. So let's just go through this so that we all are on the same page. And yes, uh, so be aware that these sessions, since my sole objective of the class is that all of us learn it properly, all of us get their questions answered. So I try to be, as precise and as explanatory as possible. But sometimes what happens is that my class might go two or three more classes as compared to this one. All right. So one more thing, at any point, if you feel that you are not able to, uh, ask questions in the class and you are not confident about the class, feel free to drop me an email. And if required, I can sit with you and do the one-on-one. All right, all those topics that you have not been clear and you get stuck, I can do a one-on-one so that all of us are, kind of in the at the same frequency during the class, instead of some of us feeling that they're not understanding anything and what should I do now. I think I will go over the video. That kind of mindset, the moment it comes in, the rest of the session will become blackout will black out for you. Therefore, feel free to ask questions. And if you face that kind of circumstance, drop me an email. We can schedule a one on one with you. That will be more comforting for us. So, I wanted to say two things. One is about one on one, second is about having that the class might spill over for a weekend. Okay, one more weekend. So, be aware about that. All right, because for me the important part is that we all learn something rather than just finishing the hours. All right. Okay, I'm not in any pressure to just finish it within certain boundary. Okay, so feel free to ask questions. I can manage the time, I can manage the classes. That's up to me. And so that should not be a worry about not asking questions. Okay, good, good. All right. So let's just try to understand a bit about Linux, and then we go into the details of HDFS. And all right. So we'll go through the understanding the file system, basic commands, and working with the web console. All right. So I would say that all of you should log in with me. Okay. Come. Is everybody on the No Big Data My Courses page? From there, you could go to the web console and log in there. Okay. Is everybody able to log in here? Yes? That will be very important. If I mean, it's okay to try it now. Because this is the inertia that, okay. So when you log in into no big data, you will have your own login and own password. Okay. So yes, I'm copy pasting it. This is the page. Generally, when you go to no big data, you can see my courses. Okay, on the right top. All right. So this is the link. All right. So yes, is everybody able to log in? Good. So B Ajan found the login. All right. Mrityunjay, are you able to log in? Everybody, please try to log in with me so most of my classes are going to be like this. Okay, most of the classes are going to be like this, and in case you have not joined the Facebook group, please join our Facebook group. This is only for strictly for student. Okay, so let me also put it here, all these links. So this is our Facebook group, and all right. Yes, Rebecca, you have a question for me? Okay, this is the Facebook group. That you can do it later, but this one is the course link. The other part was about no big data, my courses. Okay, so only the initial, it'll take a little bit time initially only. Later on, you will all get comfortable. All right, good. So this is the Facebook community. This is the direct page. This one shows my courses. On this particular page, you will get the login details. Okay. All right. Good. Dhirendra is able to log in. Yes, Rebecca. Can I help you? Yeah. Okay. So I mean, don't give up. It's not. It should work for you. Let me try. Christine's password doesn't seem to be working. Okay. So all right. Let me again show you the workflow. So if you go to my courses, you will see, if you go to my courses, you will see these links. Are you able to see this one, Mithunjay? Big data with Hadoop and Spark started with 27th August. Okay. All right. So Rebecca and Christine are facing a problem, and Kamal is also facing a problem. Okay. Right, so my directory right now is empty. All right, let me try to assist Christine. All right. Rebecca, can I make you the presenter so that we can see a screen and then I could assist you? Will that be good? All right. All right. So when you go into No Big Data and My Courses, when you go here, are you seeing anything? Let me. Can I make you the presenter and then walk you through it? All right. Let me make you the presenter. All right. Okay. I'm making you the presenter. All right. So everybody else can also, those who are facing the problem, they will also be able to fix their problem after this. All right. I have requested you to become the presenter. Yes. So yes, you can hide that password, you can copy it. Now click on the web console. Click on the web console if you are on this page. There is services under that. You can see that. There are services just below copy to clipboard button. You see Ambari Hue web console. Click on the web console and yes. So just do you see the password? Below password, you see services. There you see Ambari, Hue, and Web Console. Please click on the Web Console. Yes. All right. Yes. Copy paste the login from your first screen. Go back to the first tab. Yeah, first tab. Yes, that's correct. Yes. Yes. Copy it. Paste it here. Enter. Now go back there. Okay. Copy to clipboard. Copy to clipboard. And then paste it here and enter. Let it be that way. It won't show the password. Just paste it and enter. Good. So you are able to log in. Wonderful. All right. So this is the Linux console. All right. So reaching to the Linux console is the only little difficult step. All right. So since I made you the presenter, you have become a member of staff here. Staff here. Okay. So Mrityunjay, are you comfortable? Are you able to log in till the console? Great, great. All right. So Christine, are you able to log in? Should I take a look at your screen? All right. Okay. So I'm making you the presenter. All right. So others can also, all right. Yeah. So you want me to mute you?
That's fine. It doesn't matter.
Okay. So yeah, you can just, okay, copy the login, open the console. Okay. Yes. Paste it. Good. Now go back here. Yeah, click to copy. Ouch. Okay, so let me also try to.
When
Yeah.
I paste it from the clipboard, am I doing Control V? Do a normal paste.
Yeah, if login is being
Okay.
pasted correctly, that means
Okay.
the password should also work. Okay, so I
Okay.
will I will I will take a look at it and okay, so let me just inform one of my teammates to take a look at it.
Okay.
All right. Okay. So yes, anybody else is facing a problem? Okay, so let me make myself the presenter. All right. So till then, I'm giving you my login password, Christine, and okay, so I'll give you my login password for now. You can try this one, and later you will have your own account ready. I've asked the team to look at it. Great. Okay. All right. Kamal is not. So Kamal's question is it E or F? So the way we have done is since one machine cannot take the load, so automatically we have divided the students amongst various machines. Okay. So yes. So Kamal, what kind of problem are you facing now? Okay. Yes. Kamal, should I? Okay. Kamal is also facing the login. Are you typing or copy pasting? Okay. Okay. So you can actually try once typing and that if that works. Otherwise, I'll have to ask somebody to take a look at it. Okay. Okay. All right. So, Kamal, all right. Hank, are you able to log in here? When you go to my course, are you able to see this page called Big Data with Hadoop and Spark? No? But yours on your if you go to No Big Data and then uh, my course after logging in, can you see my courses and then okay, all right, all right, good, all right. Let's carry on. Okay, for Kamal also, it's not working. So Kamal, I'm informing my team. Okay, okay, good, good. So all right, now let's get back to what we were discussing. Now I have a console ready open here. And so one way to log in is using this, or if you are on Mac, you could go open the terminal and it'll look like this. Or if you are on Linux, you can use this. Or in case you are on Windows, you can use PuTTY. Okay, so on Windows, you might have to download PuTTY. On Linux, you can use SSH. Mac or Linux, you can use SSH for the local client. But what we did was we basically made it possible to do this login in the window so that you don't have to use these clients. You don't have to install anything. Okay, this is just an alternative alternative to web console. Okay, so in case you don't like it, then you can use the on Windows you could use PuTTY, on Mac or Linux you could use SSH. Now I'm going to use this one so that I can quickly switch between the terminal and my slides. Okay, that's the only reason. There's no difference between web console and this client. Okay, the only reason I'm using it is because I want to switch between the slides and this. Okay, personally, if you ask me, I prefer to use the web console because you don't have to type a command. Okay, so I'm logging in, and where is my password? Okay, copy the password, paste it. All right, so this is my home folder. Good. This is my home folder. All right, so in Unix everything is a file. Okay, in Unix everything is a file. The root directory, so what does it mean by file system? File system contains folders. Folders contains another folder as well as the file, and so on. So every folder can contain either the folders or the files. Files contain data. Folders just has the name that does not contain data but contain other folders and files. So root directory is called slash. Slash is the root directory, which means that there will be nothing above the slash. Okay. So since the structure is of a file system is sort of a tree, branch within a branch within a branch, and there are leaves and so on. So in this, it's a kind of an inverted tree which we'll draw. That so everything starts from the root slash. Okay, so you can create directory within a directory. You can put files inside it. For example, there is a directory called /proc. There's a directory called /proc. /proc keeps information about processes. Whole Unix system keeps all the information in the file system, including information about current processes. If you want to find out what are the processes running as of now, you can actually go to /proc and browse around. Okay, I'll talk about it. How do you browse around? And then a special directory in Unix is called etc. etc at the top level. etc is at the top level, and then there is a directory called tmp. /tmp means it is the top level directory just below root. Okay, and then /home is where our folders are. If you see the console, here, you see in my when I said pwd shows us the current working directory. Where am I right now? So for me, when I say pwd, this is my directory. Okay, to make a directory, okay, I will say mkdir. Let's say I'm saying 27 August. This is the directory that has been created. To see the list of files inside any folder, I could do ls. Okay, and then to basically see the detailed listing, I could say ls -a. Dot means current directory. This one you see here. This one, so you can see the detail. This current directory is represented by dot. There are permissions on this directory. Then the size and the login and I mean the user, the group, and the date on which it was modified and the time. Okay, so ls minus al shows you what does it mean by various commands. Okay, in case you want to find out what is ls, you could press man. You can type man. Man means manual of and space. Whatever command you give here, it will show you the information about that command. Okay, now the next command I'm going to discuss is cd command. Let's say I want to go to this folder, cd 27 August. So I just typed 2 and pressed tab and it completed because there is a directory with that name. So I said 27 August when I said cd. So now if I say pwd, now the folder is and inside the root there was a folder home, then there was my login, and then there is your login. Okay, now if you want to find out what are the logins created on this system, you could actually go to cd dot dot, again cd dot dot, and then could say ls. So you can see that there are quite a few accounts created. And Christine, what's your login? Do you tell? Which shows here on this CG, right? Let me take a look. LSCG. So is it created or not? Yes, it is created. It says cannot open the directory, but it does. If it did not exist, it will give us another error. Okay. Okay. So, all right. So it says no such file or directory in case it did not exist. Okay. So it does exist and the account has been created. Maybe the password is not set correctly. All right. So again, so I talked about two things. One is when you say ls, it shows you all the accounts created on this machine. Second, when you say ls and say SANDEEP and say star, it'll show you all the files starting with Sandeep. So you can say that quite a few Sandeep are there, and for me there are, I think, 3 directories created. Okay, so you can see that because it's a quite common name. Okay, if you say cd and tilde, or simply cd and press enter, that means you want to go home. Okay, so I have come back to my home, which is this directory. Okay, are you comfortable with this? I did went through quite a few commands very quickly. So okay, so I'll just kind of copy paste all the commands that I have gone through. All right, this is what I have done so far. And then I did, okay, I'm removing these error messages. Okay, and then what did I do? I did ls and it showed all the directories. All right, let me go back here. So this is one thing I did, right? And yes, so then I said, all right, so that was about, yes, the history command. You could actually press up key and go through all the commands. Or, yes, thank you, Azan. You could also type history to see the history of all the commands you have typed. Okay. All right. So that was the file system. So we talked about the you can see that The history command gives us the detailed and clean list of files. Thank you, Azan. And moving on. Okay. Any questions at this point? All right, moving on. So we talked about what is a file system. Now, you could either refer a file by saying absolute name like /tmp, or you could say relative location by saying dot 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 means one level up, /Sandeep means go one level up and then go into Sandeep's directory, and then inside that there should be XYZ directory. Okay, so the files have permissions, and you cannot change I cannot go into your account. Okay, for example, as I was showing you that I cannot go into CZ Big Data account. All right, so that's one important bit. Okay, so these permissions are, I mean, you can enforce the permissions with chmod. Learn a little bit about chmod. Okay, also, if you want to put some things into, let's say we want to make our own command, say ls minus al. I want to create my own command. It's very straightforward. Okay, so you could, all right, you could use a text editor called Nano. Okay, so I'm saying nano mycmd.sh, and I just created a file. And at the top, I'm telling Unix that okay, when you run this program, when you run this program, how to execute it. So whenever you're creating a shell command, this you will basically create a file. First line should be and must be this. Okay, and then you can write bunch of the commands together. And who am I, if you are having identity crisis. And yes, so once you have created the mycmd.sh, then what you have to do is you have to say chmod plus x mycmd.sh. So this basically a shell script is nothing but bunch of command saved in a file. Just that, just that it should be, its mode should be executable. Okay. Now, if you see in this, it shows that mycmd.sh is executable. Read, write, execute. These are the three attributes. These are the three things that owner of the file can do. Read, write, execute. The group of the owner, I mean, Sandeep Giri's group can do this. I mean, sorry, the files group can do these three things. And you have third one, others, who are neither in the group of this file. They can't do, they can't change this file, but others can execute this. Okay, so now, once I have done chmod plus x plus, and also, okay, now you can see that when I execute, okay, so I'll just copy paste it again so that it's clear to you what is it that I'm trying to do. Okay, so what I did was, and I'll also show you what the content of this file. Okay, cat is the command that could show you what is inside the file. Okay, so cat command shows what is inside the file, and inside the file first line must be this, rest should be the commands that you want to execute when you run this file. Okay, so to run this file you have to do mycmd.sh. Okay, Is everybody clear so far? All right. All right. Um, Hank's question is, can you send me the link to login? Yes, I can. Okay, so I'll just share with you the console. Okay, share with you. Let's say this is the console. Okay, and I'm going to give you the login. You can use my login till that time. Okay, and all right. Did you get Hank? Mrityunjay's question is okay. Um, and there are quite a few good questions. Dhiren's question is hash not a comment except for the first line? If in the first line you have to tell the Unix shell that hey, this is the program with which you should be executing this file. On Windows, the extension of the file matters a lot. In Linux or Unix, the extension of the file does not matter, but first line, if it starts with hash exclamation, signifies the name of the program with which the current script should be executed. Okay? Okay. Next question is, can we do chmod Uh, +77. Yes, you can do, but the command is chmod, not chmod. Me is missing. Okay, you have to. This is the command. So either you could do this, or you could do say 755, or okay, you could do that. 777 means you're giving permission to all. Going into permissioning would be beyond today's session. Okay, how to exit Nano would be press Control X and exit from Nano. All right, good. Now question is, what does Nano do? Nano basically is an editor like you have Notepad on Windows. Similarly, for character-based interface, Nano is the simple editor. The other editors are VI on Unix. If you're comfortable with VI, only then you start VI. It has got a little learning curve. All right, so we are able to go through the basics. Now, the command prompt on which we have been executing the commands is a place to execute any program. Okay, a question from this from Biajan is that he is getting this error. Okay, I'm sure others will also get this error. So first is that did you do chmod +x? Okay, my sample.sh. Did you run it like this? Dot slash means in my current directory there is a file. Okay, a question from Jayaprakash is, how can I open the file created by you? It is created in my directory, which is this, and you do not have permission to come to my directory. Okay. All right. In case you want to take a look, the way I can share, I mean, it won't be a possible to actually access. There are two reasons. One, you don't have permission to come to my directory. Second, you may not be on E. Right now, I'm on this machine. You may be on some other machine. Yes, Hank. Hank, we do not. So this console, what you see is from CloudX Lab. Okay. And instead of installing Linux, you can directly start using our servers. And I have given you my account so that for time being, you can get working because, um, okay, because for me, if we try to create the account for you, it is going to take a long time. And therefore, I have quickly given you my account. So go to the link which is there in the chat. In that, log in with the login which I provided, the first one. Second one is the password. Sorry, first line is the URL, then the login, then the password. All right. A question from Jayaprakash is that if you give read permission to others, yes, you can. I can give the read permission. So, but you don't need to use this one. Instead, we will have a data folder in Hadoop that will be shared with all of you. I don't have to share this data. You can create your own file. All right. You could say nano, and all right. I'll tell you what does it have. So I will tell you. I'll give you the easier idea. So you say nano mycmd.sh and then paste following. Okay, paste following, whatever is here. Okay, start editor. All right, then paste the following content. Okay, and I'm saving it, so you should be able to see it in the notes. Are you able to see it in the notes, Debrikas? And then, once, okay, now, okay, press exit, press Control X, Control X to exit the Nano. Okay, so inside Nano, when you run this, it'll show you an editor. Then you paste this content, and then you exit Nano and save and save. Good. So this is a very important aspect. Once you get into that mode of being able to a small file and execute commands, then rest of the life as we go forward will become very easy. Yes, yes, Bharanidharan. Okay, question from Bharanidharan is that how to open CloudX Lab terminal console from SSH. Which operating system are you on? Also, could you give me your nickname with which I can call? Okay, Bharani. So what you can do is on Android, it's going to be difficult, okay? Because on Android, this console may not look good. Okay, click on the console in the No Big Data My Courses and then copy paste the login and you should be in. Dhiren's question is, what is the difference between VI and Nano? Actually, there are quite a few. I would say that go into details. VI is little more developer friendly, while Nano is good for the beginners. Okay, I prefer Nano for the beginners. So Biazan's question is that the first line has to be this one, Sha exclamation, not Sha1, Sha exclamation, this. So yes, if you want to execute your script like this, dot mycmd.sh, or in case you are writing a program in Python, then let's say you want to execute in this way, then it is needed. Okay, otherwise it's not required. Okay, Anuja's question is it's not exiting from the console. So did you start vi, Anuja, or you are in nano, or vi, Anuja? Okay, press Control X and then exit. Great, great, wonderful, you got it already. All right, so I think everybody is able to create a text file. All you have to do is nano my file and press enter, type something into it, and then press Control, press Y, and press enter. That's it. Okay, Control X is for saving. Good. So now once I have created a file called my file, I could just say cat my file. You can see whatever I wrote as preserved, just like in the notepad. All right. So that's pretty much about the. No, actually, VI is a different editor, so it'll take a little bit more time to learn. In case you're not comfortable with I recommend not to start now. All right. Good, good. In case you want to try in your personal time, you're most welcome, and I would like to assist you with that. All right. So command prompt is a place to execute command. A command is nothing but a file and executed on the prompt in the following manner. You always say the name of the command, then param1, param2. Okay. When you say this command param1, param2, the Linux file system first tries to find where is this command. And how does it find? Using environment variable called path. So just like in DOS or just like any other systems, there are something called environment variables. These environment variables are basically variables available as part of the running process. Okay, so any program you execute, these environment variables are going to be available to them as well. So this command need to be in the environment variable called path. Okay, so that's for if you want to learn how to create environment variables, you should must look at the understanding of environment variables. All right. So in case, so a command could be another file. Then if it's your file, you have to give the absolute location or relative location of the file, or you put the location of your file in the path, then you can execute that program. Okay, so you can provide the parameters to your program. Okay, the way we said ls and we said minus l, that means the parameter for ls program was minus l. Okay, now so we will talk about interacting with Hadoop a while later. All right, so everybody comfortable with this? Next thing is if so there are the, so there is this directory on e.cloudxlab. I have created this file, and on my local machine as well there are some files. Okay, so if let us say that this particular notes that I'm creating right now, if I want to upload this onto my server, I'll say scp, I'll give the location of my file, Okay, this is the location on my local file system. On my laptop, on my MacBook Air, this is the location of the file. So I'm saying SCP from here to to Sandeepgiri 9034 at what is the console name? e.cloudxlab. I'll say e.cloudxlab.com. Oh, sorry, we have to say colon here at the end of it. We have to say like this. Okay, now it will ask me for the password, and then all I have to do is copy my password and paste it here. All right, so it has copied the data from my MacBook Air to my this e.cloudxlab. You can see that. SCP command is for copying the file over SSH. SSH copy, meaning to copy the data from local machine to there. Although there are many file copying system available, otherwise if you are on Windows, you can use WinSCP. Okay, you could use WinSCP. All right, on Windows you could use WinSCP. You will have to install it separately and then use it. On Mac and Linux, you do not have to really have to copy this. All right, all right. Bharni, are you with me? So you'll have to use, are you able to log in from Android? I have never tried, honestly, opening the web console using Android. Okay, so I would recommend that if you are near a laptop, log in from that as well. Okay, so log in from both. So question from Ajan is that do we need to do SCP or it's just informational? We might have to do SCP sometimes, although we will try not to use. All right, it's mostly informational. Good. So we are able to go through the very basics of Linux commands, and rest of the things we will again go into the details. All right. So as we go forward, our course is going to be very much hands-on, but sometimes you have to go through theory as well. All right, so that we all understand why are we learning something, why not some other thing, why this thing. So for that we might have to go through theory as well. All right, now let's talk about the main component. Let's build a little bit ground about it. A question to all of you: if you have 100 terabyte data, how would you store it? If let's say your let's say you are in a hostel, or let's say you are living in a community, and the whole community decides that let's build a storage of 100 terabyte. We cannot buy it from Amazon, so you'll have to build it by yourself. So what is it that you're going to do? Yes, or let's say you are trying to build your own movie storage. Okay, and you need a 100 terabyte data to store. What other things are you going to do? A question from Mrityunjay that can I use SFTP? I'm not sure. I'll have to check because SFTP is for FTP. and we are talking about copying file over SSH. Okay, so you might have to use some other system because FTP, I'm not sure if I have opened. Let's just check if I can log in via FTP. Okay, let me just log in from here. Okay, this is my desktop. I'm trying to FTP to this machine. Does it open FTP? I think FTP is blocked. Okay, I think the SFTP seems to work. Good. Yes, SFTP is working. Thank you, Mrityunjay, for that tip. Yes, you can try SFTP as well. Okay, so WinSCP or SFTP should work. All right, coming back to the question. Okay, coming back to the question that if you have to store 100 terabyte data, what are we going to do? And there are great answers. Okay, Michelle's answer is on multiple servers. Good. Yes, Ajan, that's good answer. And okay, very good answer, Swan. All right, nice. Okay, Dhiren's question is, can we use FileZilla GUI from Windows to upload? I think FileZilla supports SFTP. You can try that and also let me know if that works. All right, good, great point, Saba. So yes, I think most of you have answered this question well, and would love to know more answers because there are around only 6 people who have answered the question. Yes, Michelle. Good. Yes. Okay. Question from Michelle is, I don't know if they have servers that hold 100 terabyte data. No, they don't. All right. Because seeking right now, even if you, that's the point I'm trying to make here. You will learn this part that if you increase the size of the disk, what happens here is that your ability to read the data actually gets impacted because though you have increased the ability to store, the reading speed is lower. So I can say that two hard disks, each of 1 TB, are are twice faster than one 2 terabyte storage because with 2 terabyte storage, the speed is still 7400 RPM. While when both the hard disks are working in parallel, they can cater to two users at the same rate at which 2 terabyte machine is catering. All right, Christine, you are just one step ahead. So, all right. So, all right. Harsh's question is archive it in external drive. Good. Swan's question is that storage should be 3 times more than storage data. We'll come back to that. That's a little advanced question for now. Good. So yes, most of you have suggested me this. That take 100 1 terabyte drives, and then once you have taken 100 1 terabyte drives, you can connect them to the network and then mount them, and that way you'll be able to store humongous data. Right? So what you can do is you take these 100 drives, connect them to the PCs, let's say two drives in each PC, and then connect these, say 50 computers to a single network. Okay? And then in the network, you mount these drives into a single folder like network shares, and then and then from there you can access it. Do you see any problems with this approach? Do you see any problems with this approach quickly? Yes. So what we are trying to show here is that we have created each drive as a single folder and then connected it to the main folder. Yes, that's correct, Christine. It is slow. Michelle says that connectivity problems. Yes, connectivity is actually going to be a big problem. Yes. Any other? That's correct, Anuja. What if one of the NAS fails? Exactly. What if drive 1 fails? A very important point from Deepak: availability. Availability means that in case one drive fails, we might have backup. Let's say we build a RAID 1 kind of system whereby every drive is backed up on the same machine into another drive. Okay, let us say we build kind of system that every drive is backed up on the same machine. What if what if the network get disconnected? The overall availability will take a hit. Yes. Good, very good question, Babu. His point is we cannot store a file bigger than 1 TB. Okay, and you will understand the design of HDFS if you keep this point in mind. Okay, we cannot store files bigger than 1 TB. Brilliant set of answers. Okay, to search for data, we have to go through all the drives. Wonderful answer, Swan. And yes, correct, correct, Hank. All right. How about data integrity? Brilliant, brilliant answers. Now, let I think you have answered all the point. What about failovers and backups? What about how would you distribute data uniformly? Is this the best value for money? Okay. And let's say there are some movies that are starting with A. All of those, let's say we came up with a schema that all the movies starting with A go to these computers, B go to this computer, C go to these computers, and so on. We kind of create a mapping between name of the movies and the location they're going to go. Now, this will not be uniformly distributed. Therefore, we'll have to continuously work on uniformly distributing it, and therefore, this is going to be a problem. Accessibility. One of you have answered this availability way. The same thing is actually accessibility, meaning let us say today is Independence Day and people want to watch the same movie. Now, since the same movie is only stored on one computer and the hard disk on which the data is generally stored has a slow moving header which actually moves physically. So when many people want to read the data, only one will be able to read data at a time. Therefore, the overall performance is going to be pretty poor. So to solve these issues, yes, Christine, the storage will be skewed as per Christine if there are too many in one letter. Correct. Yes. So these are the reasons why there was a need to build a new file system. So Google came up with this file system called Google File System to store the data from across the globe, to store petabytes of data at a single place. And therefore they needed a new file system because existing one were having this issue. So what they did was they did something wonderful. They bought the old hard disks from people, connected them, and ran their software so that the data is distributed uniformly and they get a single file system. And you are going to learn that part. So they basically built the company out of the scrap. Okay, out of the the useless drives. Some people are having 5 GB drive, 10 GB drive, and so on, and they stored data in that. The petabytes of data they stored in the used and in the low end hardware, just because of the power, just the power of software. Okay, just because of the software. Correct, Swan. Good point. All right, moving ahead. Yes. So the way they built the file system at GFS, the same paper when they published, and the as I was telling you in the last session, when there was a the what was his name? I'm pretty poor at the names. So there was a researcher who was trying to build his own search engine. He was stuck at a point that he was not able to store the data. And lucky for him that Google published that paper, and he followed that paper and created Hadoop and Hadoop distributed file system. So Hadoop distributed file system is based on the Google file system, and the way it is designed is that there are two kinds of nodes. One that keeps the index of what is where. Those are called name nodes. So there are go-to guy called name node that keeps the record of what data is where, and that this is called information about data, and therefore it is called metadata. It's a net So name node is a network service just like your web server is. It continuously runs. All of these things are network service. They continuously run and listen to you a- at a port. Okay. And this metadata about where is what file is stored in the name node. So earlier, as we were trying to create, we were actually trying to create this main folder where we'll have the information about what data is where. Similarly, in HDFS, the same thing was created in a more sophisticated manner and called name node. So name node only keeps metadata. All right. And then data nodes store the data nodes store the actual data. Yes, thank you, Harshvardhan. The name was dog cutting, the person's name who created the Hadoop, the file system. He was the one, along with other people. He started Hadoop. All right. So here you see that data node know about what is there inside your files, while name node only knows about the file names and their size and where are they located. All right. Now the important bits. The files are not as such kept on data nodes. Files are split into blocks of 128 MB. This 128 MB is called block size. Block size varies from file system to file system. So if you are using Cloudera, they come by default with 64 MB, while in case of Hortonworks, they use 128 MB chunk. All right. It helps fitting very big files into small disk. One of you had has raised this concern earlier that you cannot store data which is huge. Therefore, if you cut the file into small blocks, distribute it across multiple nodes, then and keep the record, this information that this file has got these many blocks and is located on this machine, this information is called metadata, and that is stored in name node. Okay, so keep doing it. Splitting something into blocks also helps us distribute the load to multiple machines, and it optimizes the data transfer. All right. So now, so far distribution has been done very well. Okay, so we are able to distribute the data, but what about failure? Okay, in case one of the node fails, okay, the same data, same blocks have every block on HDFS has multiple copies. These multiple copies are called replication factor. By default, the replication factor is 3. You can change the default value to something else, as well as for individual files, you can change the replication factor by your choice. If you think that, okay, I don't need too many copies of a file, it's not too important for me, you can reduce the replication factor for that file. In case you feel that a particular file is too important for you, then you might want to create more replication factor. You might want to set a different replication factor. All right. So that's called, this is replication. In case one of the node fails, which means blocks, all the files whose blocks were there on that particular node, those files have lost one block. But the two copies of each block is still there in the network, and therefore it will try to rebound its replication factor to what it was promised to the user, what it was promised to you. Therefore it will automatically start copying the replica, because still you have two copies, only one is lost, so from the remaining replicas it will rebound the replication factor. All right. Okay, so we talked about two things. One is that we talked about three things. There is one node called admin node, which only has information about what is where. There are individual machines, multiple machines, who keep only the data, not the information about folder and anything. And these individual nodes keep the, okay, these individual nodes keep the data in the form of blocks, which is cut. And also keep in mind that last block is generally smaller than 128, because not everything is exactly a multiple of 128 MB. You can change this for the installation. And there are replication of every block. So in case one machine loses, all the data is recovered using other machines. Okay, so these are few of the questions. Let few of the few of the aspects of the design. Question from Ajan is that, is HDFS always 128 MB? The answer is no, you could keep something else. A question from Jayaprakash. So you can change, so let me complete the answer to Ajan. So yes, by default in hot and work systems, the default size is 128 MB, but it is up to you. You can change it. All right, you can change it. So let me try to show you the name node and data node, and then we will also talk about rest of the parts. All right, there are quite a few questions. Yes, Harichandran. Yes, very good point, Harichandran. Let me repeat. Okay, so question from Jayaprakash says, why 128 MB? Not possible to be more than 128 MB. It is possible to keep 128 MB, but if you have a big file and you have only one block, then if you have two big blocks, then the purpose of have splitting the file will, you will keep on losing. If you have two small files, that means, if you have two small blocks, that means there'll be too much of metadata. So it's a fine balance between not too much of metadata and having dividing the file, having the distribution. So some people did a research and they came up with first 64 MB and then now 128 MB. Question from Anuja. how this copy of blocks is arranged, like two copies on next block or a random nodes. So the way it happens is there cannot be two copies of, there cannot be more than one copy of a block, meaning always the copy has to be somewhere else, otherwise it's not a copy. In case one node is having more than one copy and that node goes down, then the purpose of having a copy is lost. Therefore no two copies on a single machine. Okay, it'll be, so the way it happens is when you copy the data to Hadoop, so first it'll try to keep the first copy as close to the user as possible, meaning you are uploading the file. See, I am on e.cloudxlab. If I'm uploading a file to HDFS, first copy is going to keep on e.cloudxlab. It will try to keep. Second copy will be on the same rack, and third copy will be somewhere off the rack. We'll talk about what does it mean. Okay, good. Regarding the admin node failure, I'll take those questions later after the break. What if something happens to metadata? I'll talk about it later. Okay, Swan, was I able to answer your question? So it's not the distance, it is the architecture of your data center. Question from Pankaj is last block remains unused? Not really. Last block will be a smaller one. So it is not, having consuming too much of space. A question from Hank, how to split the data blocks to each node? So that's a control you don't have. Okay. All right. Yes, Azan. It sounds like as if every block has to be 128 MB, but it's not. Okay. Okay. I'll talk about name node failure after a point of time. Okay. How to split the data blocks to each node? So this splitting of the data happens by HDFS. It is something called replication placement policy. Okay. We will understand that. Block placement policy, and uh, you do not have a control over. You do not have control over where HDFS is going to place data by default. Okay. None of the tools give you that control. All right, let's take a quick break and I'll discuss the questions after the break. Break for 10 minutes. Okay, back by 9:51 p.m. IST. Okay, I'm not sure about your timing because there are people from all different timings, so I'm going with my time zone. Okay, thank you, Christine. Let me put this one. Is that correct? All right, let's take a break for 10 minutes and come back. All right, so I'm back. Should we start now? All right, great, Christine. All right, should we start now, everybody? Yes. Great, wonderful. So I think everybody's back and let's start. Okay, so I have skipped a couple of questions because most of the questions were related to the topics which we are going to anyway deal with. Now, I want to answer a couple of questions. Suppose a file is having 129 MB, the data will be stored in two blocks. That's correct. What about? Not really, not really. So there will be two blocks. Okay. One would be 128 MB and second one will be 1 MB. All right. So when I say the block's default size is 128 MB, all I meant is that the last one is going to be smaller. Okay. And the other question is, so all right, let me try to explain what does it mean by a block. Okay. A block is actually a file created on data node. Okay. So every block has got an ID and the data is stored on the data node. Question from Mrityunjay, can we telnet to CloudX Lab from Windows and execute command? So we are not supporting telnet because telnet is not secure. Instead, we are using SSH. Okay. There's a minor difference between telnet and SSH, that SSH uses, is a secure shell while telnet is not. Therefore, we stopped using telnet. All right. So you might have to install putty. Good. All right. So most of you had a question about the name node failing. Okay. We will talk about this in detail. Now, first question is from all of you that this name node is going to be overloaded because this is how we typically think. But this is not the way it happens. We always imagine that there would be somebody called name node. We will always interact with name node that, hey, here is my file, go and store data on. But this is not the right diagram. Here, in this case, name node will become the bottleneck because every data is coming through name node to you. Okay, every data is coming through name node to you and so on. Okay. All right. So now, so that's the typical server bottleneck is that all the users are accessing data through a central system and central system is bottleneck. But in reality, this is how it works. This diagram displays how the communication actually happens. You use a command or you use a client or a driver to interact with Hadoop. Now this driver, whenever you are asking this driver, hey, give me this file, first it goes to name node, gathers all the data about the file, and then starts directly talking to the data node. So it's only the metadata for which name node is consulted, not for the actual blocks. Actual blocks are fetched from individual data node. Okay. All right. Is everybody able to hear me? There is one student who is not able to hear. Yes. All right. I've just messaged him. Okay. Let me explain again. So typically, we imagine that whenever we are trying to read the data, we will just our single point of contact will be name node. Okay, but that's not the case. Instead, we go to name node, and then when we go to name node, uh, this is what happens. Okay, so you use client the way we are using ls command to talk to the local file system. We're going to use Hadoop ls command to talk to the file system. Okay, so we go to name node, meaning using our client, we talk to name node, say, hey, can you give me this file? And name node responds. Name node responds with the list of data nodes, okay, with the block number. Then this client directly starts talking to data node and reads the data. So you can see that if this client wants and it needs all the file, it can actually read files from all the systems parallelly, and that will make it very fast. Okay, so only the network is going to be the block, not the file system read speed. So you can see here that uh, you can actually read the data from multiple data nodes because a file might have, let's say, three blocks, and each of these three blocks are located. These three blocks are located on different machines, different data nodes, and therefore you can read it parallelly. That is the magic of distributing data. All right. Is it clear to everyone? The same diagram is displayed in little hodgepodge way. Here it shows that this person is trying to write the data. First, it goes to the name node, informs the name node that, hey, I want to write the data. I want to modify the data. And then name node says, okay, fine. Why don't you go to these data nodes and create the blocks there? Why don't you go there and create these blocks and come back to me? Okay, so it's a name node's duty to give the block ID and data node's duty to create those block IDs with the data. Client will hand over the data to data nodes, not to name nodes. Okay, and then again, when the client, meaning when you're using a command, Hadoop FS, which is a client, it's going to talk to name node first, gather all the information, and then read the data from everywhere. Also, please keep in mind that the client, when it writes the data to the data node, every block get copied between the data nodes. Okay, it never happens that client has to create all the copies. It leaves up to HDFS, up to the data nodes to start replication amongst themselves, so that the client does not take too much time to create file. If you as a client, if your client library, the command, if that command has to create all the three copies, there are high chances that there will be there will be errors. Therefore, the replication is done amongst the data node. It's between the data nodes. It's not between you or your client and the name node. Okay, so this is how the replication happens. All right. Now, question from Deepak is, who is client or driver? Okay, who is client or driver? Hadoop provides you the command called Hadoop fs minus ls. That is your client or driver. I'm going to quickly demonstrate to you this one. See, you see there are so many files I have on the HDFS. Okay, so this is the command to talk to HDFS. So this is called driver. There are quite a few drivers available off the shelf. Some in Java, some in Python, some in a normal Unix command, and so on. Okay. A question from Babu. Is there a concept of transaction when replication happens? Good question. Very good question, Babu. Let me try to explain this and let me ensure that if I have understood correctly. Okay. Question is that is there a concept of transaction when replication happens? Okay. So I would try to answer first that is when we are creating a file in Hadoop, is it safe? The answer is yes. And so that happens before replication starts. Okay, replication is not part of the transaction. The way it happens is it's a very valid question. Question is that let's say there are two people trying to create the same file. How will HDFS avoid it? Let's say me and you trying to create slash TMP, because in slash TMP everybody can create the files, right? So we are both of us are trying to create the same file at the same location. Now both of us will first go to name node. Now name node makes sure that it reads, it answers to the queries in a sequential manner. Okay, so whosoever is picked up first will get to create the file. The other one will get an error saying file already exists. Now imagine that Anuja's command went to name node, created the file, same file which I was trying to create, but Anuja got the first opportunity, and then that file got created before me. Now, name node has booked the slots. Name node has booked the slot, saying, okay, fine, I'm making an entry for you, but the actual data writing you have to do by yourself on data nodes. What happens if let's say while writing data to data node your connection breaks, right? Will this file remain with the name node? The answer is no. So the concept is exactly that of transaction. So you first go to name node, create a temporary file. You first go to the name node, create a temporary it creates a temporary metadata entry saying Anuja is trying to create such and such file, and once Anuja's client has finished writing the actual data into data node, then Anuja's client has to go back to HDFS name node, informing that, hey, I'm done. Can you mark it permanent? And then it marks it permanent. What happens if, let's say, it could not confirm? If it does not confirm after a certain time, the temporary node which was created, temporary metadata that was created, will disappear and will make a place for other one. Okay, does it make sense to you, Babu? Is that all right? A question from Anuja. Are you going to teach how to install Hadoop? Quick answer is no, but I'll give you the directions on how to install. There are two ways. I mean, here is some link which is being used by everybody. Okay, I'm just sending it to everyone. So here you see that we provide you two kinds of installations. One is how do you install on the cluster, and how do you install uh, say on virtual machine. Generally you would not require to install, because that installation process on multi-node cluster is quite buggy, and on single node this virtual machine and other things are very much painful. Okay, so please go through these instructions. They will guide you enough. In case you get stuck, let me know. All right. So this is how the file write happens. So is everybody clear about file read and write? All right. So the answer is very simple. So you go to the name node first, and then you go to the data node second. Okay, because name node contains the information about all of this. And also note that all of these complications about talking to name node, data node is not too difficult. I mean, it's not nothing to do with you, because all of this complexity i- is taken care by this guy. Okay, so and again, let me so let's talk about the transaction part once more. So let's say you are trying to create a, let's say, a file here at name node level. Once that's done, so first you'll go to the name node. Name node will allot you the data node IDs, and then you go to the data node and try to write them. And then once you are done with writing on the data node, then you go back to name node and confirm that I am done. This is what happens. So you are the client, you are using you are using these file systems libraries to talk to name node. So first command is that you give a command, and then this library internally gives a command to name node, and then it goes and creates the data, and you get the confirmation that the data has been written. And then next happens is that it says that mark it at the name node, and that's it. Mark it to the name node that, hey, I'm done with writing the file. In the meantime, once that's done, afterwards the replication would start happening. Okay, it won't wait for replication to finish before giving you confirmation that I have written a file. All right, so I hope that everybody's on the same page related to the file writing. Yes, Anuja. A question from Jayaprakash is, replication should happen in the same cluster? Not really. Not really. Sometimes replication could happen on different cluster. Cluster, when I say, probably you're talking about two different locations of machines in a data center, correct? Yes. Replication could happen. One copy could even go to another cluster. All right. The next question which you have been asking is name node the single point of failure? Okay, the answer is no. There are quite a few techniques. In Hadoop 1.0, this is what we did. Name node kept the data in the local storage, and the same data we kept on copying to the network file system. Okay, so all right, so this name node keeps only the information about files and directories and the block names and block locations, not the actual data. And this data is loaded in the memory, as well as periodically we keep on creating image of this on demand. We kept on creating image of the name node. Okay, and so since creating the snapshot of the entire metadata into the disk is very costly affair. Okay, every time it can't be done. Therefore, name node keeps on creating something called transaction log. Okay, or edit logs they call it. So it keeps on, so name node on the disk keeps data in two forms. One is called the image. Image is periodic snapshot, which you, or on demand snapshot, which you create whenever you want. And then edit logs after that point of time. Now question is, why such? Why not on every file creation it writes to the name node in the disk? If it does so, what will happen is the whole process of this image creation, it will be too costly. Therefore, therefore, it just keeps on making logs that, okay, this file got edited, this file got modified, this file got created, and so on. So those edit logs combined with image depicts the current state. It's just like the keeping a journal when you are accounting about the various transactions in your organization. So day-to-day activities you keep it in journal, and periodically, say once in a week, you keep on formalizing it into accounting system. In the similar way, image keeps the older snapshot, while edit logs contains the recent changes, and if you take the older snapshot plus recent changes will give you the data. So earlier, long back, correct, Jayaprakash, then the latency will happen. Yes, we'll talk about more about what happens in name node fields. Now, since we keep these two things, name node and edit logs, in the disk, if name node fails, we will basically recover the current image using these two things. Hadoop command gives you that functionality to combine the older image with the edit logs to give you the latest metadata. Now, there are one chance is that name node got shut down. We can recover it by picking up image and edit logs. What if the same whole machine that contained the disk on which this was written goes down? Therefore, we earlier kept a copy of this image, this metadata image plus edit logs in a network location. Okay. Now, later on, we started keeping a secondary name node. Secondary name node again needs to be brought back manually the way we were doing it earlier. Nothing big deal. Secondary name node essentially contains the image and the edit logs and therefore is not of a use. Okay. Now, in case name node fails, we will create secondary name node using image and edit logs, and that's it. Okay, but secondary name node is not really great. The better one is standby name node. This is the current architecture we are following in HDFS today. All right, so this is the architecture we are currently following. All right, this is something worth explaining to all of you. All right, I will explain to you, and we will also touch upon the zookeeper. So name node has something called standby. Okay, name node has something called standby, and so standby is just a mirror image of name node to an extent that in case name node dies, we have standby who will take the place of name node immediately. And in case the older name node comes back, then that name node will be the standby. So you keep the two copies up and running, but you always use one. The second one is just for the rainy day. It's just for the day when name node fails. Correct? So basically, n- The idea is to keep the exact image of name node up and running, and user should not even feel the difference in case name node went down. Okay, so both of name node and standby give the attendance to zookeeper saying, hey, we are up, we are up. And zookeeper also, at zookeeper they mark themselves that, hey, I am the the current node who has been surviving well. And at zookeeper, that is the idea. So standby, so there is, let's say zookeeper contains something called current. Okay, and so zookeeper is kind of a file system. So it has, let's say, current name node, and let's call name node. Okay, name nodes, or you can say standby. All right, so it's like this. Now both of these nodes have exactly same algorithm. Both of these nodes go to zookeeper and first check if there is any current node. If there is no current node, it will become the current node and remove itself from the standby. Similarly, the same logic applies both the sides. So both name node and standby keep on competing for being the current node via Zookeeper. Zookeeper is like a whiteboard to which is consulted before talking to name node. Okay, so the client library talks to Zookeeper. Zookeeper, from there it reads who is the current name node and goes there and start talking to that name node. And this name node, whosoever is current name node, will keep on informing standby about every changes. Similarly, every data node will keep on informing standby exactly in the same way data node keeps on informing name node. Therefore, standby is always a mirror image of name node. So both name node and standby have exactly same behavior, as well as data nodes have same attitude or same behavior towards standby as they have for name node. All right, does it make sense to you, Harshvardhan? Correct, Saba. So it looks like SQL Server always on, and Zookeeper is the witness. So Zookeeper is kind of a whiteboard from where everybody consults. It's like when we have sales calls, so we write on the whiteboard that, hey, I'm calling this particular person, so that others do not call that person. Okay. Similarly, I am the name node, so that other does not become the name node. So that kind of model is followed. Is the volume okay now? All right. All right. So, yes, standby is replica of name node. And after some time, when standby becomes the name node, the name node will become the standby. Good? All right. All right. Is it better now? Wonderful. Wonderful set of questions. Okay. So, all right. There's something called HDFS Federation. Okay, this is also an important aspect which happened as part of a Hadoop file system 2.x. Okay, so what does it mean by HDFS federation? Let us say you have 100 data nodes. Let us say you have 100 data nodes, and but your file system is growing at a very fast pace. Although your file system do not have many files, do not have much data, but your file system is having too much of, too many files. Okay. If there are too many files, there will be too much of metadata. If there are too many files, there is going to be too much of metadata, but data node will be free. In such kind of scenarios, Okay, in such kind of scenarios, when you have billions of files, since name node cannot grow beyond what fits into the name node's metadata, if it doesn't fit into the memory, it wouldn't work. Okay, and memory, as in RAM, has got its limitations. Therefore, okay, so it has got its limitations, and yeah, all right. So, all right. So basically, the all right. Let me try to explain this again. So when you have too much of metadata, you would like to have name node, multiple name nodes. Okay. Now this information, that which file goes into which name node, you can mark it into something called mount tables. Mount tables are kind of configuration files, not really server, and these configuration files are available to the client library. So client library consults the mount table configuration file first before going to a name node. Okay, this way you can divide This way, you can divide the workload amongst name nodes. But again, if you look at it closely, haven't we gone back to the architecture which we started with, right? When you have multiple folders containing multiple folders and connected with a configuration file that, okay, if this kind of data, then go to this machine and so on. Yes, so it is similar kind of model, but this is very rare. When you have too many files, only then this kind of model comes into play. All right, but sometimes a question from Anuja is, name node's limit is up to 128 MB? Not really. Name node can have as much metadata as it wants. Okay, name node can have as much data as much that fits in the memory. If let's say you bought a really good computer with say 100 GB RAM, then it can store the metadata up to 100 gigabyte. Do I make sense, Anuja? Okay, so a question comes here that what is SB1 and SB2? It's actually standby. Standby of 1 and standby of 2. Okay, whatever we learned in the previous talk. Yes, you got it. All right. Good, good. Now the important part here is they look like two separate file system, like as if we are having two separate HDFS. For one folder, go to this HDFS, and for another folder, go to that HDFS. This is the kind of federation model it is. But the important part here is, its important part is that sorry, the important part to understand here is that this. Are you able to hear me clearly? Because the wire just got pulled out. All right, that means nothing has broken. Okay, so yeah, so the only difference between although prima facie this looks like there are two file systems and we are talking to two file system, the only difference is that data nodes are same. The data nodes are same for name node 1 and name node 2. Okay, question from Babu. In a typical cluster, how many name nodes are present? Only one name node. Okay, this is only a very, very special case when your name node has really got full. Okay, a question from Anuja. Name node resides on local disk or HDFS. Okay, so name node is basically the HDFS. All right, name node is the HDFS. Name node is the one who is giving you the HDFS. All right. When you say Hadoop distributed file system, it is the name node, meaning the whole structure of the folders is stored in the memory in the name node. And a copy of that structure is kept in the local system on that machine. A question from Jayaprakash, what kind of configuration we do have to do in Mountable? We'll have to basically maintain the mount tables are actually not HBase. Mount tables are not RDBMS. These are simple configuration files which contain information like this is how the configuration file will look like. So they'll contain okay XYZ tab IP address of node 1, okay, or XYZ my data 1, let's say. This is how it would look like. Good. And then we'll have these two. Okay. And then we'll have rest on, let's say, node 3. Okay. I'm just giving you a pseudo configuration that for rest of the files, you go to node 3. All right. So this is HDFS Federation. A quick recap. So name node contains whole folder structure as metadata. This metadata is kept in the memory. It's on demand. You can save it as an image to the disk. Okay, this whole image is parsed to the image is paged or parsed or snapshotted into the disk. And metadata looks like this. The name of the file. Okay, how many replicas have been promised to the end user? What are the block IDs? Block ID as in each block has got an ID. So if you have three blocks, there will be three different IDs, and also the location of those block ID on the data nodes. Okay, so that's how metadata looks like. Next is what kinds of metadata. Okay, metadata means list of files, list of block of each files, file attribute, the list of data node for each block, file attributes such as access time, replication factor, file size, file name, directory name, and so on. Now, it also keeps something called edit log or transaction log. Okay. Okay, so transaction log or added log, basically whenever you're making change to metadata, every change is recorded in the edit log. Now, a question from Dhirendra. Each machine in the network can have one data node or multiple data node. Ideally one. Okay, ideally one. You can force it to have multiple data node by tweaking the port number and so on. When I say data node is a process. Just like the way when you run a web server, mail server, or say SSH server, and 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 any say Tomcat, all of those keep on running in the background, and that's what make them server. Okay, So basically, the server keyword has two meanings. One, server as in physical hardware, and other, server as a service which keeps running in the background. Right now, there are quite a few services running on my computer doing various kinds of jobs. Okay. In similar way, data node is a service which keeps running on a computer, listening on a network port. What does it mean by port? When you ask a website that give you, let's say you go to Google, when you type in the browser google.com, you are talking to google.com server. Server means there is a process, there is a program running continuously and listening on 80 port. So when I say google.com, actually I'm talking to the service which is running inside the premises of Google's data center, and I'm talking to that service to give me the data. I'm talking at a port, the network port called 80. When you talk to a service via SSH, the way we are talking right now to e.cloudxlab here, this I'm connected to the e.cloudxlab. Here I'm talking at 22 port. When I drop an email to somebody, I talk at 25 port, and so on. So that's how. So since every process is allocated a port number, since every process is allocated a port number, therefore the all right. So since every process is allocated a port number, therefore every data node listens on a particular port. And the way we define data nodes is that generally all the data nodes will be listening on exactly same port 50070, and sometimes we can force a machine to run multiple data nodes by tricking it, by making a change, by saying that let's run one data node on this port and other data node on different port, because two processes cannot listen on the same port. Swan's question is how on-demand paging in name node happens. So generally, we schedule a command to keep on doing the snapshot. Okay, if we are running only one name node, then we have to schedule the process to keep on creating a snapshot. All right. Bernie's question is, do we have any limitation on memory for name node? If two name nodes, then how will be RAM allocation? So yes, these two name nodes are going to be on different computer, and memory limitation is there on name node. So because all the metadata stays in the name node's memory, therefore, therefore, right? So since all of the metadata stays in the memory. Therefore, if there are too many files, it's going to consume a lot of metadata store. Okay. Therefore, if you have two name nodes, not standby, but two name nodes, federated name nodes, then some of the metadata will be in one, some of the metadata will be in another. All the metadata for this directory, okay, meaning this also, like it has XYZ folder and so on, that will again go to name node 1. Therefore, the metadata got divided because of federation. All right. A question from Jayaprakash. Uh, what happens if name node memory is full? One more name node will be created? No, it will give an error saying your memory is getting over and you may need to increase the, it will actually shut down. Okay. So in case name node's memory is going down, you need to keep on monitoring it and keep on provisioning more RAM. All right. A question from Dhiren: does each data node has a copy of name node? The answer is no, because this metadata cannot be so easily copied onto all the machines. All right. Okay. So I hope I have been able to answer your questions. All right. Let's try to do a little interaction with the HDFS. What do you say? Yes? So yeah, further question is, so where is the name node's data? Name node's data is on the same machine on which name node is running. Name node is running on a.cloudxlab and it is stores in the local file system on that machine. That's correct, Jabrakas. So yes, so name node should have more processing power, CPU plus RAM both, okay, as compared to the data node. A question from Swarn. A question from Swarn. Let's say we have 1 terabyte of data. What should be the size of name node? It's a very subjective part. Let's try to look at. Okay, let's say you have one file of 1 TB. Okay, so quickly, who can help me with number of blocks in the number of blocks in 1 terabyte? 1024 into 1024 divided by 128. Okay, these many blocks. Okay, so into 3, so these many block ID entries. Okay, let's say we have got one file of, and replication factor we have set is 3. So since there are these many blocks and every block is having 3 copies, so there are 3 times, so these many entries. Okay, if each entry is taking 1 kilobyte, so it's going to take not 1 kilobyte, let's say 10 bytes. Okay, that, or say 20 bytes. So how much is going to be 20 bytes divided by 1024? Okay, these many kilobytes. Okay, so this case 1 terabyte only took 1 kilobyte of data. Okay, all right, all right, so looks weird. Okay, let me try again. So question to all of you: out of 1 terabyte, how many blocks? Yes. All right, so let me try to explain the formula. What I'm trying to, so this is not exact the formula per se. Okay, so we are trying to compute the metadata size. Okay, metadata is not data, it's data of data. Okay, so right now we are trying to compute how many total blocks would be there, and every block, if every block entry is taking 20 bytes of data, okay, that means how much is going to be the metadata storage. it just it's just a list of block IDs, right? Do I make sense to you? So 1 terabyte is going to have 8192 unique blocks, and every block is replicated 3 times, so a list of block ID is this much. And if each block ID's size, block ID, not block ID size is say 20 bytes, then 20 into this is what is going to be the metadata size. Dhirendra, Azan, do I make sense at all? Very good questions, Jayaprakash. Let me try to answer your questions. Okay, all right. Ajan, let's try to do the math, and then try to see if I do make sense or not. Okay, I've tried to give you an estimate. Okay, it's a very brilliant question, and this needs to be answered, and you will face this question again and again. Yes, that's correct, Azan. It's not really too big a maths, it's just the concept. Yes. So basically, we are trying to count total block IDs, because if you look at uh, let's say we are maintaining a register that, okay, we have these many files. Some files are on this data node, some files are on that data node, and some files on that data node. So if we are maintaining a register, and we are counting, we are tracking block IDs, then these many block IDs are going to consume only this much of metadata. I've tried to oversimplify it. Okay, I'm not counting anything else. I'm just imagining that my metadata is only list of block IDs. Okay, so it's like pointer to the data, not really the data. Never mind. So okay, so is everybody convinced about this part? It's a very good question, and I should answer it, because we are going to take couple of decisions as we go further, as we go in future in Spark or in MapReduce. Everywhere this maths is going to be important to us. Okay, all right. So we are essentially counting the IDs of blocks, because we are making a pointer. Good, good. So Dhirendra got it, Azan got it, and is everybody on the same page? Why only this small data for 1 terabyte? This small metadata on name node? Okay, good, 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 Christine. All right, Haricharan got it. Okay, let me try to okay, Haricharan, let me try explaining. So this is what? 1 terabyte divided by 128 MB. Okay, and this is, let's say, total number of unique block. Okay, let me call it B. B multiplied by 3. So total blocks are these. This is after replication. Okay, and then total size. Okay, so if each entry, each block ID takes 20 byte, then total size is 1 byte is equal to 1 character. And if your block ID is assigned 20 characters, then it'll take 20 bytes. A question from Saba that I understood the logic but just reference pointer enough to identify data block when client is looking. So yes, I'm basically trying to assume this part. Maybe this is equal to 64 kilobytes. In that case, the metadata will be 3 times. Okay, 64 bytes. Okay, there are quite a few questions, and then I missed a couple of questions earlier. I was thinking that I'll answer that. Let me keep a track of questions because those are important. I'll answer these questions soon. Okay, Mrityunjay, since as I was telling that every block is going to be multiplied into 3, there are 3 copies of every data, and that too consumes the information, that too consumes the metadata, right? That too is a metadata because every block has got 3 copies. So effectively, it's going to consume 3 terabyte data on the data nodes. Anuja's question is block ID size is fixed or varied? Block ID size is generally fixed. Okay, I think I'll show you. It's a small string of 10 characters. So right now let's just assume it to be 20 characters and then we can do whatever we want. Good. So if you see here that we have done something good here that we computed it. Now let's take a different angle. Let's say that we have on an average 10 megabyte file, or let's say 200 MB file on an average. Okay, so if instead of a single 1 terabyte file, then how many files? How many files? Okay, out of 1 terabyte, 1024 into 1024, these many MBs divided by 200. So these many files, I'll just round it off. So total files is this. Good. So these many files. How many unique blocks? Quickly. 2 into this. Correct? Into 2. Okay, so good. And with 3 replication factor, because every block is going to be copied 3 times from every file, so it's going to be 3 times. Okay, good. these many total blocks will be this, and metadata is only the block IDs. So we could say 31 this into 20 bytes. Okay, so if we multiply it by 20 and divide by 1024, therefore it's going to be this much gigabyte. Question from Ajan is why 2? Because question is for each file, for each file of size 200 MB, how many blocks? 128 MB plus what's that? 272 MB, right? 2 blocks. Okay, how many files? We are saying uh, how many files out of 1 terabyte is 1 TB divided by 200 MB is this much. Sorry, this is MB. Thank you, Christine. Yes. All right. So here, okay, so the important maths I have tried to demonstrate that actual data is 1 TB, right? Actual data is just 1 TB in both the cases. Here also, okay, here also it was 1 TB, while here also there was 1 TB. Just a second, did I make a mistake here? This, let me try to understand this into 20 divided by 1024. Yeah, it's actually half GB. Okay, 0.5 GB. Yeah, zero point 0.6 GB. Okay, so that's not much, but yeah, there is a huge difference. Earlier it was in KB, now it is in MBs. Is everybody with me on this? No, actually, see, for every file, so there are how many files? These many files, right? For every file, there are going to be 2 blocks, right? Because every file is 200 MB. Therefore, total number of blocks are these many for all the files, 5243 into 2. Ajan? So this 2 is basically there, since there are, it's 200 MB, right? For every file, how many blocks? 2. And for 5000 files, 10,000, right? And for unique blocks, yes, for unique blocks, there's a replication of 3, then this much. And the same thing is happening on both. So this much metadata is being consumed on name node as well as on the standby if you are having that. Okay, both standby. I think I goofed up. Yeah, I think I goofed up. So No, I think you're right. Okay. So yeah, I think I goofed up here. So this into 20 divide by 1024. Yeah, it's actually, yeah, it's in MB. Okay. So yes, it's basically it's not too big a difference here. Yeah. Now, imagine that there was a file of say 10 MB on an average, let's say 20 MB files. Okay, if you do that maths, and it's going to be humongous in that case. Okay, so if you take the same maths, right now what happened was instead of one block per data, it became two blocks, 1.5 blocks. Therefore, the data has become little higher than it was expecting. But if it is 220 MB is the average size, then the maths is going to be very different. Okay, the maths is going to be very different because the total number of files are going to be really high, because assuming on an average, let's say you are handling the LinkedIn. Okay, I'll take another example, LinkedIn case. Okay, in case of LinkedIn, you have 1 kilobyte size of pictures, I mean profile pic, or say 10 KB. Okay, now if you have 1 terabyte, say 1 million pictures, these many, so for 1 million, the total number of blocks is going to be how many? 1 million, 3 million, right? For every file there's going to be one block, and for 1 million profile pics there's going to be 3 million block IDs. And effectively, if you see 3 million block IDs, and so 3 million block IDs means if it's consuming only 10 bytes, which means or 20 bytes, this million bytes. Okay, this million bytes, so around 60 MB will be metadata storage consumption. Okay, just because of the small files. Okay, so HDFS is not great when number of files is too high. Number of files is too high. Okay, HDFS is not great. So what we do generally, in case the number of files keeps on growing, number of small files keeps on growing, what we do is we create the compressed format. Okay, we'll talk about compressed format as we go ahead with MapReduce, and as we discuss in detail during Spark, what does it mean by compressed format. So if you have to process or store millions of profile pics, what you are going to do is you are going to combine them into one zip kind of a format, and then store it in HDFS. Now question would remain that do I need to unzip all the blocks first, or how does it happen? So that's the magic of new formats such as RC file and ORC file that comes into play. Okay, all right, so that's pretty much for today. And initial classes take a little bit more teething issues, and rest becomes very smooth. Okay, so I can assure you, you are going to have a good time as you go ahead. And all right, and try to do as much as possible the hands-on. My team has created your accounts. For time being, it's just the quizzes. More more work is coming along. All right. Thank you, Christine. All right. Thank you, Rebecca. All right. So thank you Sabha, thank you Deepak, thank you Hank, thank you Pankaj, thank you Sandeep, thank you Biazan, thank you Leeladhar, thank you Anuja, thank you Swarn, thank you Michelle, thank you Jaiprakash, thank you Haricharan, thank you Dhirendra, thank you Madhusudan, thank you Mrityunjay, thank you Bharidharan, Malko Jata, thank you Harshvardhan. Alright, have a great day ahead. I look forward for the class tomorrow. So Christine, the password issue, the account is fixed now. You can try again. Okay. All right. So my team has fixed your account, and Kamal was facing problem, right? I miss Kamal. Could you please check it is done? It's working fine. All right. Bye bye. Great set of question. Wonderful set of queries. I'm actually enjoying it. So keep the questions coming. I okay. I'll try my best to answer your questions. All right. Bye bye. Good night.